So we're going to work through a few of these problems here to get you ready, or just to make sure you're ready for the test. Questions 1 through 8. Write the inequality in interval notation. So to do this, we write it with our parentheses or brackets, and it's our endpoints. So number 1, because we're given 2 endpoints, we're going to list our 2 endpoints, negative 256, comma, 100. Now next to those, we'll have brackets or parentheses. Parentheses are included, what am I saying? Parentheses are not included, brackets are included. So if we look at this here, negative 256 and 100, to determine if they are included or not, we look at our inequality signs. Because the negative 256 is just less than x, it's not equal to it, it's not included, so we would have a parentheses. The 100 is less than or equal to it. Because it's equal to it, we would have a bracket. Questions on number 1. We can look at number 3. Now, number 3 is unbounded because we only have one endpoint. It means we're either going to infinity or negative infinity, one of the 2 directions. And that's going to depend on whether x is bigger or smaller than 174, negative 174. Well, here x is greater than negative 174. So since it's bigger, we're going to infinity. Now, infinity and negative infinity, neither one of these will have a bracket. Infinity and negative infinity will always have a parentheses. Now, the bracket or parentheses with negative 174 will be determined by our inequality. Because it is equal to it, we would have a bracket. Questions on these first 4? Any other questions on 1 through 4? Questions on 5 through 8? Well, 5 would be what? Because 6 is less than x, so our values of x would be bigger. And because it's equal to, we'd have it here. It is flipped. We do have the x on the right instead of the left, but we are saying x is the bigger value. Any other questions on 1 through 8? 9 through 14, when we write these set builder notation, we have our brace, our number, the group, so our group of numbers, and then our description. So our group of numbers in our description. With any interval, it's understood to be all real numbers. And if we have all real numbers, it's just brace x bar. So for number 9, it would be all real numbers. But since it gave it to us as an interval, our description as an interval, not an inequality, we do have to rewrite this as an inequality. Now, because we do have 2 endpoints, that means our x value is going to be in the middle, telling us that negative 24 is indeed less than x is less than 87. So that's the basic form. We do need to figure out if either one of those is equal to 1, both, or neither. Can x be equal to negative 24? Well, it has a parenthesis, so that is a no. The 87, brackets tell us yeah. Questions on how we wrote that inequality. Now that we have it as an inequality, we can write the set builder notation. So we have brace x bar because it is the set of all real numbers. Since it's a set of all real numbers, we have brace x bar. And then we can put our description in, which is our inequality. And that's it. The set of all integers, x is greater than or equal to 200. Already gave it to us as an inequality, so we're good there. Now to find the number set, because we're not looking at the real numbers, we're just looking at the integers, we'd go brace x as an element of the integers, our z with 2 lines, such that we just plug our inequality in. X is greater than or equal to 200, and we're done. Questions on this here? Good so far? We ready for the next one? We'll look at one more of these here. The set of all real numbers except -2. Well, we're looking, our group is the set of all real numbers. So that gives us our group of numbers, brace x bar, set of all real numbers, brace x bar. Our description is what? Except -2. So x cannot be equal to -2. And that's it. Questions on set builder notation? All right, let's look at systems of equations. So systems of equations on the test. The two main ones that are on the test, you can solve by any method. You can solve them by hand, you can solve them in the calculator. It's up to y'all on which one you do. Do y'all want to see it by hand or in the calculator? We can do it in the calculator. If y'all want to grab one, or at least especially write the steps down, I would do that. Now the first thing we're going to want to do is rewrite this as an augmented matrix. So we want to write our coefficients and make sure that each of these equations is written in x, y, z form. X first, y second, z third. And the number without a variable is on the other side of the equal sign. So our first one is x, y, z equals number. Second equation is x, y, z equals number. Our third equation is x, y, z equals number. So going across the top, our coefficients would be -1, -5, -5, 2. Our second equation would be 4 for x, -5 for y, +4 for z, and +19. And our last one would be 1, +1 for x, +5 for y, -1 for z, and -20. And our dimensions would be a what? 3 by 4. We have 3 rows and 4 columns. Now to type it into the calculator, first thing we're going to do is what? Second matrix. Then we're going to go over to edit, and we'll hit enter. We're just going to pick that first matrix. We're going to pick matrix A. Now we're going to type the dimensions in. It is a 3 by 4. And we'll type our numbers in going across the top. So -1, -5, -5, 2, 4, -5, 4, 19, 1, 5, -1, -20. We good on how we got that typed in? Yes? Now, if you want to do it by hand, you can do it by hand. There's nothing wrong with that there. Once we get it all typed in, where do we go? Second quick. And then we go second matrix over to math. And then we go up or down to find RREF. Second matrix, and then we select the one we want and hit enter. And then the last column going from top to bottom is our X, Y, Z. So for this here, it'd be -2, -3, 3. And the solution would just be that point, -2, -3, 3. Questions on our systems? So the two questions on systems of equations on the test, you can do it by any method. You can do it in the calculator, you can do it by hand. It's your pick. There is a bonus one, bonus question. It is over systems, but it's going to ask you to do it by hand. You don't have to do it. If you do it and do it by hand, and get the correct answer, you'll get full points. If you don't do it, it doesn't count off. If you just give me the answer on the bonus, that's not going to get you anything. I need to see it worked out. But questions on 15 and 16? There is not a no solution or infinitely many solutions for systems of equations on the test. Not going to show up. I do not like putting those on the test because, for the most part, y'all's first thought is not that is the correct answer. It's normally I did something wrong. So I don't like putting those on the test. The only time I will is I will explicitly state that it could show up. Systems of equations, there is not a no solution. There's not an infinitely many on the test. Let's look at 19 through 24 are the second matrix over to math, second matrix A. You're welcome. Write the augmented matrix form. Augmented matrix and state the dimensions. So we write it as an augmented matrix. We need to make sure the variables are on one side, numbers on the other, and they're in the form of x, y, or x, y, z. So 19, the first equation does have x, y on the same side. They are in the correct order. Same with the second equation. So how would we write the first equation? It would be 7, -41, 29. Our second equation would be 46, -2, and 19. Now the dimensions would be what? Rows by columns. So it is a 2 by what? 3. That's it. Questions on number 19? We can look at number 20. So the first equation, 6x plus 4z equal 2. Variables on one side, numbers on the other. We are in alphabetical order, so we're good there. Now there is no y, so that just means we're going to fill it in as 0. Second equation, y minus 7x plus 4z equals 15. That is not written in the right form. We have what? The y and x flipped. Now, since they are both on the same side of the equal sign, All we got to do is switch the x and y. Now, since there was not a sign in front of y, it is positive. Since we had minus 7x, the x value, that 7, is negative. Now, the third equation is in the form x, y, z, so we're good there. Now, our numbers going across the top for the first one. 6 for x, 0 for y, 4 for z, that's equal to 2. Our second equation would be negative 7 for x, 1 for y, 4 for z, 15. And our last equation would be 6 for x, negative 1 for y, 3 for z, and 20. And this one here would be a three by 4. Questions on augmented matrices. Do we feel good with these here? Do we need to see another example of an augmented matrix? Okay. Transformations, the transformations. Now, the biggest thing with transformations is take it one transformation at a time, and I would highly suggest sticking to the general forms. I will leave those up there during the test, so you will have those. Now, the only one that's not listed up there is horizontal stretch and shrink. I'm not doing any on the test that have horizontal stretch or shrink. I did put some in the review sheet. They're not going to show up on the test. So, 25 through 29. Is there one of those in particular that y'all want to look at? If not, I'll just do 25. To start with, f of x equals 6x squared minus 1. First translation is translated 3 units up. Now, the general form for our vertical translation, our movement up or down, is f of x plus k, where k is the amount that we move it up or down. Now, since we're going up 3, the value of k is positive 3. So we'll plug positive 3 in for k. If it moved down 3, we would plug negative 3 in place of k. So k is our amount that we're moving the function up or down. So we have it all put in, we're good to go. Now we can replace f of x with its equation. Because we still have f of x, we can just substitute its equation in for it, which tells us that we have 6x squared minus 1 plus 3. At this point here, we don't need the parentheses, so we can drop them. And lastly, we can combine like terms. We'll give it a name. We'll call it g of x. So after we translated this function up 3, our new function is 6x squared plus 2. Now we have one other transformation. We have a vertical stretch of 2. Now the general form for vertical stretch or shrink is a times f of x. But since we're applying it to g of x, our new function, that middle step, we're going to say it's a times g of x, where a is the amount that we stretch or shrink. Well, for us here, the amount that we're stretching or shrinking this function by is 2. Vertical stretch or shrink, we don't have to do anything to a. We just take that amount of the stretch or shrink and plug it in. So we have 2 times g of x. Now, since we still have g of x, we can go on and replace it with its function, telling us that we have 2 times our 6x squared plus 2. Last thing we have to do is distribute the 2. 2 times 6x is 12x squared. 2 times 6x squared is 12x squared. And 2 times 2 is 4. Now, what we name it really doesn't matter. I'll call it h of x. But since we have done our 2 transformations, this is our final answer. And on the test, you won't have more than 2 transformations being done at one time. Questions on 25? Are you ready for another one? 26 or 29? Which one do you want to look at? 29. F of x equals 5x minus 1. We want to translate it left 7 and reflect it across the x-axis. Now, our left and right, our horizontal translation, general form is f of x minus h, where h is the amount that we move it left or right. Now, up and down, it's fine. I didn't denote it because, again, this left and right can be a little tricky. Our value of h, the amount that we're moving left or right, is 7 units to the left. Now, because we're going left, the value of h is indeed negative 7. And at this point here, we're going to plug negative 7 in place of h. Now, that negative and negative is going to make a positive. Now, normally we would just write x plus 7. We would put those two negatives together and make a plus. I went on and just wrote it below it. Now, at this point here, we don't have f of x anymore. We have f of x plus 7, which means every x in f of x's function has to be replaced with x plus 7. So that means we have 5 times our x plus 7 minus 1. Now at this point here, we can distribute the 5. 5 times x is 5x. 5 times 7 is 35. And 35 minus 1 is 34. So after that movement of 7 units to the left, our new equation is 5x plus 34. Now the other transformation we have is to reflect it across the x-axis. Now our reflection across the x-axis is normally negative f of x. But since we're applying it to g of x, it's just going to be negative g of x. Now at this point here, we can replace g of x with its function. And then distribute that negative through. We're going to multiply every term by that negative. Which is going to make our 5x negative. It's going to make the 34 negative, giving us negative 5x minus 34. And that's it. Questions on 29? Questions on these transformations? So again, with any of these transformations, I would take it one transformation at a. We're ready for the next problem. All right. I'm not worried about 31 or 30. We're going to move on to this here. This is your 32, 33. We can look at 32. This one here, or what it's called 30. Our scalar. We're multiplying this matrix by a scalar. So that means for us here, we're multiplying all the elements in this matrix by 1/4. Now you can do all this by hand, 1/4 times 16, 1/4 times 24, 1/4 times 30, and 1/4 times 9. Or you can just grab a calculator and tell it to do 1/4 times 16, which is 4. 1/4 times 24 is 6. 1/4 times 30 is 15/2. And 1/4 times 9 is 9/4. So we have 4, 6, 15/2, 9/4. And that's it. If you want to write this one as a decimal, because 15/2 would be 7.5, 9/4 is 2.25. That would be the same answer. I would prefer fractions. If we start getting repeated decimals, we're starting to have to approximate. Let's leave them as fractions. Questions on 32? Which one do we want to look at next? 33, 34, 35? One of those that y'all want to look at. $34. So when we look at this here, we need to apply our scalar first. So the first one, we're going to multiply everything by 2, yes? So let's skip a step here. 2 times 3 is 6. 2 times 1 is 2, and 2 times 4 is 8. Minus. If I'm doing these by hand, I'm going to leave the negative there. Just one less thing to worry about. Negatives and negatives. I'm just multiplying that second one by 4. 4 times 8 is 32. 4 times 6 is 24. And 4 times 7 is 28. So we get this here. Now the next thing we did in class is we take the first two matrices and subtract. 6 minus 32. It's going to be negative 26. 2 minus 24 is negative 22. And 8 minus 28 is going to be negative 20. And again, we could do that subtraction in a calculator. We can let it do it for us. Now we're adding 3 to each one. Negative 26 plus 3 is negative 23. Negative 22 plus 3 is negative 19. Negative 20 plus 3 is negative 17. Questions on this here? Now that is a good question. Could we have just said 6 minus 32 plus 3 at this point? That's all we're doing, isn't it? 6 minus 32 plus 3. 2 minus 24 plus 3. 8 minus 28 plus 3. Yes. Because 6 minus 32 is still negative 20, or negative 26 plus 3 is still negative 23. 2 minus 24 is still negative 22, plus 3 is still negative 19. 8 minus 28 is still negative 20, plus 3 still gets us negative 17. We'll still get there. We're just cutting steps out. Any questions on 34? We good with 34? How about 35? What is it? Undefined. Why is it undefined? Because the dimensions are different. I might throw one of those on the test. I feel that's a little different than our undefined with systems of equations or solving equations, because literally it is, we look at one. Are these two matrices the same dimensions? If not, undefined. So if the dimensions are not the exact same, they're undefined. That one there, I feel comfortable putting that one on the test because it's looking at it 3 by 3, 3 by 2. Not the same. Does not work. Do we feel good with these matrix operations? That brings us to 39 through 41, I believe. 38 through 40. Love the fact that these get back on. Let's look at 39 and 40. So here, write the equation of the line and describe the slope. On the test, I just want you to write the equation of the line. You're not going to have to interpret the slope. So if we look at 39, the first thing we need to do is to find the slope. y2 minus y1 over x2 minus x1. What are our two y values? Well, 90 and 40. Corresponding x values are 40 and 15. Because we went 90 minus 40, we're going to have to go 40 minus 15. At this point here, we can type that entire thing into the calculator, let it do it for us. Or if we did this by hand, 90 minus 40 is 50. 40 minus 15 is 25. And 50 over 25 is 2. Questions on how we found the slope? Now, we want to get in the equation y equals mx plus b form, the slope intercept. Set form. But they don't tell us the y-intercept. Now, we could use the slope to slowly work our way back there. But it's going to be easier to just use point slope form to get there. We can plug 2 in for the slope. Darley, pick a point. Which one of the two? Give me the y value of it. The point you want to use. $40. And its corresponding x value is 15. So we plug the slope and the point in. Now we just need to get y by itself. First thing we're going to have to do is resolve those parentheses. Now our 2 times x is 2x. 2 times negative 15 is going to be negative 30. Now the only other thing we need to do to get y by itself is to add 40 to both sides, because our negative 40 plus 40 is 0. Telling us y is equal to negative 2x plus 10. Found the equation of the line, so we're done. Questions on 39? Be ready for 40. Yes? Looking at this here, can anybody tell me what the slope is? That's fine. Let's use our points. Because this other point isn't told it to us directly, but it is 0, 65, because it intersects the y-axis at the y value of 65. Yes. Now our two y values are both what? 65, yes? So we put those in. Now, because they both have the same value, the way I order the x-axis or the x variables is up to my choice. I'm going to put the 5 first. I'm going to say 5 comma 65 was the first point, x1 or y2, x1. 0, 65 was my x1, x2, y1, x1. Numbers. 65 minus 65 is what? 0. 5 minus 0 is 5. What is 0 divided by 5? It is 0. Zero divided by 5 is really saying what times 5 is 0? 0. We can have 0 on top of a fraction. We cannot have 0 on bottom. So the slope is 0. I'm going to use our 565 as our point. Now we do need to distribute this 0. What's 0 times x? 0, yes? 0 times negative 5 is 0. So what happens to the entire right side of this equation? It becomes, still got to get y by itself, so we're going to add 65 to both sides. Minus y is equal to 65. Questions on any of this here? Questions on anything we've done so far? Anything on this review sheet? We good with all the questions that we've covered? Yes?